This is the graph of the derivative of a function y equals f prime of x. Choose the graph of its function y equals f of x from among the following. Alright, so same idea as previous examples, but we're going in the opposite order here. So in order to do this, let's see. We're going to pay attention to basic principles. The first is that whenever a derivative is greater than 0, that tells me the original function is increasing. Wherever a derivative is less than 0, that tells me the original function is decreasing. Whenever a derivative is equal to 0, then I have a relative minimum or relative maximum, or possibly neither, just depending, but there's a critical number there. Alright, so here and here I have critical numbers. So I have critical numbers at x equals -2 and 0. Alright, so that's one thing to pay attention to. So if we look at all the options, this one has a critical number at 1. So that doesn't work. We can throw that out as an option. This one has a critical number here at 0 and at +2, which is close, but still doesn't quite match up because we're looking for critical numbers at -2 and 0. The next one would have a critical number at -2 and 0, so that's still in the game. And this one has a critical number here, which is not quite -2, and here, which is definitely not 0. So we can throw that out as an option as well. So it looks like this is the only one left to work for us. Now there are some other principles we could have used if it didn't rule out all the others. And the other principles that we can use here. So the first derivative here is positive. So what that means is the function should be increasing on that interval. So from -∞ up to -2. And then it should be increasing again from 0 to infinity. And then the function should be decreasing on the interval from -2 to 0. So if we go down here and see if that pans out, it looks like it does because we're decreasing on this interval and then we're increasing here and here. So that matches up.